morning, everybody. I've got 8:30 by my clock, so let's see if we can get started here. How's everybody doing on day 3 of the conference, or 4, depending on how you count? Doing okay? All right. So this is an introduction to Spring.NET for Java developers. So I'll make an assumption, tell me if I'm right, that most people in this room consider themselves to be Java developers. Okay, that part's good. How many of you are familiar with .NET by actually working on it? Number of you. Okay, good. That's great. For the rest of you, I'll assume that after all these years you've certainly heard of .NET, so we can get past that one. So, set some ground rules for the sort of the focus of this talk. Generally, this talk is about applying your Spring Java skills to the .NET stack. There are a couple of different scenarios where that makes sense. One is you just happen to be building applications and components in .NET. So there's value in this context. There's also value here in the application interoperability scenarios, where we have applications in our business written in .NET and also applications written in Java, and we need to interoperate between the two of them. And the third scenario that is also very common is what we call architecting software systems and heterogeneous platforms with homogeneous capabilities, which is an insanely complicated way of basically saying if you're building applications in your organization in Java and building applications in your organization in .NET, it's often the case that these want to be architected with similar capabilities available to both platforms. So in a perfect world, even if we're in different language and technology stacks within our organization, the overall suite of capabilities that would be available to each of these applications built in these disparate platforms would have great similarity to them. And so that's another scenario where the Spring Framework for .NET can help us out. A little bit about myself before we get too far into this talk. I've been developing software for the better part of the last 2 decades in a fairly wide array of languages, starting out in Lisp of all things and then working my way through C and C++. Spent some time in the Java stack and then Visual Basic, today in Ruby and C# for the most part. I'm presently an engineer with Spring Source Division of VMware. I'm the co-founder of the New York City Alt.NET user group. We meet monthly in Manhattan to talk about exciting .NET topics. I'm also the co-organizer of the New York City Domain-Driven Design user group. We meet monthly to talk about domain-driven design in a variety of different platforms, certainly .NET and Java, but also disparate languages like JavaScript, Python, Perl, Ruby, these kinds of platforms as well in the context of domain-driven design. I'm a contributor to a variety of open source projects. Probably the best well known is the Hibernate Object Relational Mapper, which you of course will know as the .NET port of the Hibernate project in the Java space, but also things like NDBUnit, and in my capacity for Spring Source, I'm the program lead for the Spring Framework for .NET, which of course is also open source. In addition to that, I'm a Microsoft MVP, this year in Visual C#, I suppose, and in past years in things like ASP.NET and solution architecture categories as well. Let's talk about our agenda for our talk briefly. We're going to talk a little bit about the design goals of the Spring Framework for .NET in the context of Spring for Java. We're going to spend some time doing a little feature tour where we're going to talk about the features that are in Spring.NET. We're going to compare and contrast those with the features that are available to you today in Spring Java so you can understand where there's overlap and also where there's differentiation between the two platforms. We're going to spend a little bit of time talking about tooling that's available in the .NET stack to facilitate your use of Spring.NET. We'll spend some time talking about Java and .NET interop scenarios and how the two frameworks can actually play together in order to enable some of those scenarios. And then we'll spend a little bit of time exploring the rest of the ecosystem, the Spring ecosystem in .NET. You know in the Java space certainly that the Spring Framework for Java is certainly one amazing piece of software, but it's really only one in a much larger ecosystem of corresponding, correlated, related projects that help make up an entire sort of collection of utilities and capabilities that you can use in building applications. We'll spend a little bit of time talking about where there's correlation between what's going on in the Java space with these multiple projects as well as what's going on in the .NET space. So let's start with some design goals. First, the question, why a .NET version in the first place? So one of the real reasons for this is that there's an awful lot of overlap between the .NET space and the Java space in a lot of areas. Certainly in the very early days, even the Java language and the C# language were really almost on parity with each other. What's happened over the course of the last probably 8 or 10 years is that the languages have sort of begun to bifurcate more and more, and so today there's lots of syntax in each language that doesn't really have a good allegory in the other, although the two are sort of playing neck and neck catch up with each other, so over time probably parity will return. But one of the things there is that because of this great overlap between the two technology stacks, a lot of the architectural concepts and patterns that evidence themselves in Spring Java are equally applicable to the .NET stack for the same reason, right? Commonalities include things like compiled languages, intermediate compilation to Java bytecode versus Microsoft Intermediate Language on the CLR, the idea of garbage collection, static typing. All of these kinds of things mean that the way in which we think about architecture for our software solutions in the Java space really does have applicability to the way we want to think about them in .NET. Because of a lot of that similarity, they also share a lot of pain points, right? So a lot of the things that are difficult and annoying to deal with in the Java space are difficult and annoying to deal with in the .NET space as well. So the question becomes, wouldn't a .NET port of Spring Java be of value to someone? So back in 2003, an initial minimal port was created. And back in 2003, you could actually almost run the code through a translator and just take the Java code and immediately get almost compilable C#. So the minimal port back in 2003 was actually pretty simple for a couple of reasons. One was that language parity, but the other was that if you remember what Spring Java looked like in 2003, it was a lot simpler, a lot less involved than it is today. Right? A lot fewer capabilities means a much easier porting exercise. But this porting exercise in 2003 was essentially to get the sort of core dependency injection capabilities moved over to the .NET stack and get something beginning to run. Obviously, since 2003, we've continued to enhance and expand the .NET framework, the Spring for the .NET framework, with a lot of additional capabilities, which we'll talk about here today. Conceptually, though, this exercise was very similar to other ports that had been going on at the time. Things like Spring Python, Spring ActionScript, a lot of these things, right, which are essentially saying, look, there are a lot of really good concepts in Spring Java. Never mind implementation details for a moment. There are a lot of good concepts in Spring Java about how to architect and engineer applications. And other platforms, whether they're .NET, Python, ActionScript, these kinds of things, could benefit from that same mindset, that same approach to building applications. So what were some of the goals? We wanted to let developers focus on business value and not infrastructure. To sit down and say, what is the business problem I'm trying to solve, independent of the infrastructure concerns that I have to worry about? The approach in the .NET stack to dealing with this was to do what we called embrace and extend the .NET framework. So the .NET framework, when you get it, ships with a whole number of class libraries and so on that provide capabilities that you can use to build applications, of course. But anybody who's actually tried to sit down and build an application in .NET realizes that while the base class library provides all kinds of wonderful functionality and capabilities, it doesn't provide everything you need in order to build software systems. Certainly not reasonably complicated, scalable enterprise software solutions. So one of the plans for the Spring.NET framework as a design goal was to say, let's fill in those gaps. Let's say where the base class library does something, let's let it do it, because that's going to be sort of the Microsoft way to do it. But when we come across something that the base class libraries don't provide us, then we're going to extend and fill in those gaps. The other value that we wanted to do was we wanted to promote this plain object component model. We know this in Java as POJOs. In .NET we have the concept of POCOs, plain old CLR objects. So the same idea, the idea that the code I write should be decoupled from a lot of the infrastructure. To the degree that I can write them as just plain old objects without any dependencies expressed on infrastructure items, then that gives me a lot more flexibility in where I'm going to actually be able to use these objects. Our techniques for dependency injection and aspect-oriented programming wanted to be non-invasive to code. We didn't want you to have to add those things to your objects literally, expressively in your code. We wanted the framework to be able to add those things for you. Part of this goal was we wanted to say we want portability of key business assets, typically things like domain objects and so on, to be portable across different technologies. And in the .NET space, one of the things that's very interesting is that the base class libraries that Microsoft provides, and this will come as no surprise to anyone, are very good at providing infrastructure overlays on top of other Microsoft technologies. But they tend to be lacking when it comes to providing infrastructure for non-Microsoft technologies. So as an example, it's not surprising that the .NET framework makes it very easy for you to interact with Microsoft SQL Server, but a little bit more challenging for you to interact with Oracle or MongoDB, or those kinds of things. It should come as no surprise that Microsoft's framework makes it very easy for you to use MSMQ as your message bus, and a whole lot harder if you want to use something like TIBCO or RabbitMQ or ZeroMQ or one of the other million MQs that are out there today, right? So One of the values for the Spring Framework for .NET was acknowledging that, if we're in sort of this polyglot world where we can't necessarily say I'm always going to be able to buy one vendor's technology stack from all the way at the top to all the way at the bottom, then it would be a really good idea if we had a way to make it as easy for you to interoperate with those other technologies as the .NET framework makes it easy for you to interact with the Microsoft variants of some of these things. So in a sense, we can think of this as a technology integration platform to say, I shouldn't have to care that my enterprise standardized on Oracle and I still want to build applications in .NET, or that my enterprise happens to use TIBCO as a message bus, but we happen to be building that application in .NET. We should have a solution for that, and the Spring Framework offers that. Quick overview. Even though the initial minimal port of this was essentially run the thing through a translator and get it into C# quickly at a very low level, beyond that, this has not been a blind port of the Java code base. So we don't take Spring Java and run it through a translator and call it Spring.NET. It is a conceptual port. We are looking at the things that Spring Java is doing and deciding on a case-by-case basis that is or isn't something that would have applicability in the .NET stack. However, one of the things that the Spring Framework for .NET does benefit from is this sort of conceptual maturity of the Spring Framework for Java. And by conceptual maturity, I'm not so much talking about whether or not there are bugs in the code. I'm talking about the mindset and the thought process that goes into the concepts and the organization and the architecture of the framework, and what the architecture of the framework suggests about perhaps a good suggestion of a way to actually architect your solutions using the framework. This is as compared to other .NET offerings, right? Java as an ecosystem is a couple of years older than the .NET stack as an ecosystem. As a result of that sort of jump start or head start in the process, the Java space has learned a lot of very painful lessons that the .NET space is still learning today. And unfortunately, in many cases, repeating some of those same missteps in certain areas. But one of the things that Spring.NET benefits from is we get sort of the learning that led and feeds into Spring for Java is informing the way we think about building the Spring Framework for .NET. We wanted a broad set of features to address all tiers, so not just server-side stuff, but also client-side stuff, not just server but desktop, not just desktop but web, these kinds of things. One of the things you can do with the Spring Framework for .NET is you can pick and choose. You do not need to adopt the entire framework whole hog, so to speak, all at once. You can incrementally adopt the pieces, parts that make sense to you. So after the minimal port in 2003, the project really started in earnest in 2004 in order to continue to add features to the framework. We do a new release about once a year with incremental releases about every 6 months. So that's more or less the pace we're on for the most part. The current release of Spring.NET is 1.3.2, and it supports literally every one of those versions of the .NET framework from 1.1, 2.0, 3.0, 3.5, and 4.0 today. However, we've made a decision that we're only going to support .NET 3.5, 4.0, and the newly released .NET 4.5 stack in the upcoming Spring.NET 2.0 release, which should be coming in about a month or so. We hope to get that done by Spring 1, but we missed on a couple of things. But the point is that there is broad support for this. By the way, it's worth noting that .NET 1.1 and 2.0 aren't even any longer supported by Microsoft, right? So they've even deprecated product support for those things too. It does have a comprehensive reference manual, so not only API reference, but also usability, configuration, all these kinds of things. And it also provides 16 or more sample apps as well, showing different implementations of the framework for different scenarios. The two primary ways to get the Spring Framework for .NET are to go to springframework.net on the web, and where you can download the entire thing all as one item. Or how many people are familiar with NuGet? 1, 2, okay. So NuGet is, we can think of it as a package dependency manager in the Microsoft space, which allows you to basically bundle up assemblies, state dependencies of your assemblies on other assemblies, and when you ask for one, it walks the dependency tree and gets all the dependencies for you, adds them to your solution. You can sort of think of it as Maven Lite, although that's not really a fair comparison either, because Maven, of course, is also a build system, and NuGet is not any of that. It's really just a package delivery mechanism. Probably the closest allegory conceptually is more like the Ruby Gems ecosystem, where it's not about build so much as it is about adding things to your solution. But one of the benefits of NuGet is that if you go to springframework.net and try to download the whole Spring Framework for .NET, it's about a 45 meg download or so, because it's got release and debug binaries for all of those different versions of the framework. It's got the documentation in PDF, HTML, CHM, all these different formats and so on. And it's got all the sample apps and all the docs and all the rest of that kind of thing. And as a zip file, that's pretty massive. The benefit of NuGet is that if all you want, for example, is the messaging infrastructure for Spring.NET, you can add that package to your solution, and it'll bring down the two dependencies that come with that, the Spring Core and the Spring AOP assembly. And that's just a couple of $100K. So NuGet allows you a much more granular way to sort of consume the framework and add it to your solutions. Talk a little bit about the ecosystem itself. Here's a quote from the Burton Group. Spring.NET can provide a consistent cross-platform programming model for enterprises invested in both Java and .NET development, and it's especially valuable to enterprises with developers cross-trained on both platforms. Now, it's not the case today that there are actually as many cross-trained developers on both platforms as there used to be, right? Probably 5 to 6 years ago, it was the case that more people sort of existed with one foot in the .NET space and one foot in the Java space and sort of seesawed back and forth between the two. But as both sort of ecosystems have increased in complexity, people have had to make a choice. I'm either a Java guy or I'm a .NET guy, because I can't keep up with the pace of change in both of these platforms. And so this is now, I think, less about developers being cross-trained and more about enterprises at a system architecture level being cross-trained or having a cross-requirement for both stacks. People often ask the question, who is using Spring.NET? This is just a sampling of some of the organizations. Career Builder, Barnes & Noble, those kinds of organizations. You'll notice that for the most part, these are relatively large organizations. One can imagine they do not have single source technology under their roof, right? In fact, they've probably got much more than even just Java and .NET, right? But you can sort of get a sense as to who some of the users of the framework are. So let's do a feature tour. Let's take a look at some of what we've got here. So the Spring.NET framework is very comprehensive. At its core, we offer things like dependency injection. We have aspect-oriented programming, as well as a library of a number of out-of-the-box aspects available to you to use in your solutions. We have an ASP.NET Web framework. This works with ASP.NET Web Forms as well as MVC. We have declarative transaction management, which, of course, you're familiar with from the Java space. We also have explicit support for the ADO.NET framework. This is Microsoft's sort of low-level data access technology for talking to relational databases. Anyone who's ever tried to work with ADO.NET realizes that it was intentionally sort of a low-level API because they wanted to allow you to sort of do anything you wanted to with a relational database with it. But because it's a low-level API, just about anything you want to do takes 7 and 12 method calls to get it done. So we provide an abstraction on top of that that helps facilitate interacting with ADO.NET data sources. We also have a portable data access exception hierarchy. So anyone who's ever written an application where the idea is, maybe the application will be deployed against, Oracle, maybe the application will be deployed against DB2, maybe the application will be deployed against PostgreSQL, knows that one of the challenges is that what comes back from those engines when they're not working right are different exceptions by vendor. So your application really, even if you're using an object relational mapper to sort of abstract away the details of some of this goo, you know that what comes back to you is different exceptions from different exceptional behavior from different of these database engines. So one of the things that we provide in the framework with this portable data access exception hierarchy is we take the responsibility of translating specific platform or database platform exceptions into a common exception hierarchy that your application can respond to. And we'll take a look at an example of that a little later on. The Spring Framework for .NET also has ORM, Object Relational Mapper integration. So the same kind of the same kind of support that you're used to in Spring Java for Hibernate, we offer in Spring.NET for NHibernate. In addition to that, the whole idea of writing services. So remember we talked about this idea of POCOs or plain objects wanting to be the way we write our code. So a lot of what happens in Windows are user-facing applications, but a lot of what happens in the .NET stack is people are writing services for things too. And these don't necessarily need to be web services, they can be other kinds of services as well. The Spring Framework provides, for .NET, provides exporters for this, which basically take your plain object and expose it as a Windows service so that people can actually make requests of it and so on. Your code doesn't need to know that it's ultimately being exposed as a service. Our framework takes care of that. In the case of WCF, so Windows Communication Foundation, very popular in the .NET stack as a mechanism for abstracting configuration of services and remote requests and these kinds of things. The framework supports dependency injection and applying aspects to WCF services. So things like retry and caching advice and these kinds of things on your WCF services. We also have a layer that deals with message-oriented middleware. So the idea of selecting your message bus, whether it's TIBCO or MSMQ and all the rest of these kinds of things, we provide a set of abstractions that works with a variety of different message buses in order to allow you to abstract that. We also have scheduling. So probably familiar with Quartz in the Java space for job scheduling. There is an allegory in the .NET space. It will surprise no one that it's called Quartz.net. We provide integration for that as well, which allows you to use Quartz.net to actually schedule jobs in the context of applications built around the Spring Framework for .NET. We have support for integration testing. So we make it very easy for you to write code that talks to your database within the context of a transaction where we deal with rolling back that transaction at the end of the test so that you're not leaving garbage around in your database at the end of integration testing. So we provide infrastructure for that. People here are familiar with the Spring expression language, right? So what a lot of people don't know is that Spell actually started out in the .NET framework for Spring and was ultimately ported over to Java. So we still have support for, obviously, the Spring expression language inside Spring.NET the same way you're familiar with it inside Java. We have a UI agnostic validation framework. Anyone who's written applications where you have the idea of a common back end and disparate front ends, right? Maybe there's a web front end, there's also a mobile front end, there's also a desktop front end, but it's all one back end, knows that UI-specific validation logic begins to become really, really annoying, because you have to write it again and again and again for each one of these platforms. We have a validation framework in the Spring.NET libraries, which is UI agnostic and allows you to code to one set of validation logic and then apply that to the different platforms. We also have a caching abstraction. The caching abstraction that you know today in Spring Java actually also started out in Spring for .NET and was ultimately ported over to Spring Java and continued to be enhanced there as well. But we also have the caching abstraction. And lastly, we also have support for the relatively new ASP.NET MVC platform that Microsoft has been releasing over the last 2 to 3 years. And we actually support all versions of MVC, 1, 2, 3, and now 4 once it's released. So a lot of this is about parity, or at least understanding where there's parity. So one of the big draws for Spring Java, we find, is this whole notion of declarative transactions, right? And we're familiar with, of course, how to do this in Java, because what we see here is a very simple bank service. It implements bank service, and then it's got a method called create, and we just slap an @transactional annotation on it. And with that, what we do, of course, in the configuration is we need to actually set up the object, but of course we add the magic annotation driven, right, in our XML config. This is minimally invasive and really, really easy for developers to understand what's going on. I have a method that should be transactional, so I place the annotation on it and it becomes transactional. So the same thing is true in the .NET space. Here is virtually the exact same code written for .NET. We still have the simple bank service. In the case of .NET, we don't get annotations. We get something called attributes, and they look just like that in square brackets. So we've placed the transaction attribute on the method. And similarly, in our configuration, we've added TX attribute driven instead of TX annotation driven. Right? So there are some differences here, but obviously at a conceptual level, the exact same thing is going on. And the mechanics about how it's accomplished in Spring.NET are identical to the mechanics of how this is actually accomplished in Spring for Java. So let's talk about the Spring Core feature set. Fundamentally, the engine that there are sort of two engines that drive virtually everything we get to do in the Spring framework for .NET. The first engine is dependency injection. We also support service location, so explicitly asking for services back from our container. As I mentioned before, we support the Spring expression language, the validation framework. We also have support for internationalization. Right? People who are writing software where we have internationalization concerns, at least in the .NET space, this becomes very, very onerous to support. There's lots of framework libraries that make it easy to do it, well, make it straightforward to do internationalization in .NET, but none of them are all that terribly easy to work with. So we have much better support for internationalization as well. We also do event wiring. So in the .NET space, it's not at all uncommon for events raised by one object to be handled by another object. And those objects, once you wire up those events, have all kinds of rules about life cycle and unsubscribing from event listeners and these kinds of things. So as part of the core feature set, we do event wiring between objects as well. We also have a high-performance reflection library. So the .NET framework offers its own reflection library, and it's pretty good. However, there are a number of cases where what we wanted to do in Spring.NET simply couldn't be achieved fast enough using the reflection library that the .NET framework provided us. And so, as a result, there is a higher performance reflection library built into Spring.NET. There's also a series of threading utilities. So, a lot of what people are starting to deal with today is multi-core processors, parallel execution, these kinds of things. Spring.NET has had threading and thread management utilities for a very long time. Even as these things are starting to find their way into the .NET framework. Today you get, in .NET 4 we got things like the task parallel library, and in .NET 4.5 we start getting the async and await keywords added to the language in order to sort of try and mask what's really going on with language keywords. But in the end, a lot of people still need to do thread manipulation, a lot of people still need to do thread local storage, a lot of people still need to do all these kinds of things with threads that are at a much more fine-grained level, and the Spring framework obviously provides for that in .NET. And as I mentioned before, we also have this caching abstraction. These are all part of our core feature set. In the case of the dependency injection container itself, we support both constructor and setter injection. Right? These are sort of common patterns for injecting dependencies into our objects. The Spring for .NET supports both of those, of course. We also have support for factory methods. So objects that build other objects register with the container. When we ask the container for the object, the factory does the work to build it. This is a great extensibility mechanism for anyone who's got objects to construct that are very, very complex or have a whole bunch of construction logic attached to them. We also have an indexer, so it's possible to ask the container for an item by index. Event wiring I mentioned before. In the context of the DI container, we support using the Spring expression language for setting and calculating values that are passed to our objects at assembly time. In the service locator scenario, we actually offer the ability to ask the container, of course, for the service back explicitly. A lot of what is done in the .NET space does not involve you actually ever asking the container for things. A lot of what we've done in the Spring framework for .NET is we have wired in the Spring framework into the life cycle of a lot of the different sort of platforms that exist in the .NET space. So in the case of ASP.NET, for example, rather than your code actually expressly asking the container for an object, what we do is we hook into the page request life cycle and provide the objects automatically out of the container as they are requested by the runtime. So you don't usually find yourself in .NET very often asking the context expressly for an object. We do it a lot in unit tests, but we don't find ourselves doing it at runtime in our applications because of the way in which we've hooked in there. But if you find yourself needing to, you can still use a service locator pattern in order, obviously, to ask the container for an object explicitly. We also support minimalized auto wiring. So we don't have, actually in Spring.NET 2.0, we actually do have auto wiring to the same degree that it exists in Spring Java. But in the 1.3.2 release that's out there now, we actually only have minimal support for auto wiring, but more of that is coming. We have component lifecycle, so the container is responsible, as you might imagine, for not only constructing objects, but also for destructing objects. In the .NET space, we have the same sort of challenge that you have in Java. The destructor is not entirely deterministic. However, the container actually, depending on how you configure the object, is able to go on ahead and both construct as well as destruct the object for you as part of the lifecycle. We also have the notion of component scopes. So the idea this is very common in two scenarios where this really starts to come into play. One is the web scenario, where we have objects that are obviously scoped at an application level, but also scoped at a session level, and also scoped at a request level, right? So all of these different scopes are available in the web context. In the context of services, in the context of exposing WCF services and so on, common scopes include per call, right? So every time we make a service invocation, we want this object scoped just for the length of that particular invocation, right? So per call at a service level as well. So the container also supports lazy instantiation, both of singletons and of other dependent objects. So if you don't want to pay the penalty to construct all of the objects at startup, then we can obviously do lazy instantiation identically in concept, at least to the way it's done in Spring Java. We also have parameterization of configuration data. The most common one of these, obviously, is to substitute database connection strings for objects that need them. But this can really be used anywhere. And so this parameter substitution in the configuration is supported natively by Spring.NET. Out of the box, so to speak, we support retrieving these from files as a resource embedded in the assembly somewhere. Via an HTTP call, so if you want to ask a web service for the configuration metadata, you can do so. And because it's extensible, you can also put the configuration data elsewhere too. So if none of these other choices make any sense for you, then obviously there's still the option of doing this at a custom level too. We support XML-based object definitions. I'm not going to spend a lot of time explaining this, of course, because anybody who's dealt with Spring Java is probably very familiar with XML. But the whole value there, of course, is the configuration of our application, and a lot of metadata that is used at runtime is not dependent, or is not rather compiled into the assembly, and so can be changed at deploy time rather than at compile time. We also have support for custom schemas. So the reality is that while we provide an XML schema that we would expect most people to use, the truth is if your configuration metadata doesn't make sense in that schema, then there is support for extending that so that you can store the metadata in other schemas too. And the point here is that the container itself is not tied to any one format. Out of the box, we support the format we recommend you use, but a number of people have some obscure use cases where storing metadata for configuration in different formats makes sense to them. We do have a separate project called CodeConfig, which offers code-based configuration as an alternative to the XML-based configuration. This project today is as a separate assembly and a separate project out there on GitHub. As part of the Spring.NET 2.0 release, its capability will be folded into the main Spring Framework release. And you know CodeConfig as the @configuration annotation approach from Spring Java. Right? So that already exists in the .NET space. It's just a separate project right now and will be folded in soon. We also support composition and importing of configuration. So the idea of configuration dependencies and the idea of composing multiple configuration files together, of course. And object name aliasing as well is supported. We also have this idea of abstract object definition inheritance. So the idea that a number of object definitions in the XML file might very well share common settings, common capabilities, common configuration values, rather than repeating them over and over again in every one of the configuration sections. What you get to do, of course, is declare a abstract object definition, and then the other object definitions can, conceptually at least, inherit from it in a sense and bring along those values. So composition, not just by saying let's take this configuration file and use it together with this one, but let's take this configuration metadata and sort of merge it in with the other several objects that want to use that same stuff. As part of this, we do collection merging. So if the base abstract definition contains a collection of items, let's say the property is of type dictionary, for example, we actually do collection merging so that the derived configuration dictionary values are merged in with the parents. So it's not a matter of either or, it can be anded together and those kinds of things. We also support method injection. So injection of just a method, and obviously that requires replacement typically, right? So if you have an object that's just about what you want, but not quite, except for one method. We can actually inject a method to replace one of the existing methods in there. Yes. Yes, it is. That's correct. Yes, this happens at runtime. You'll never actually see this in code, so to speak, right? It won't appear in your C# file. But yes, this is done by runtime proxying. That's quite correct. We also have a bevy of type converters, which allow you to register your own. So if you have metadata you want to place in your configuration file that needs to be converted to type-sized information, you can register your own. We have our own collection of these. You can override them as well. You can register type aliases. So if you have complex name types that you don't really want to find yourself repeating all over the place, we allow you to register type aliases to make shorthand reference to these same types elsewhere in the configuration. As I mentioned earlier, we have support for internationalization. We also support hierarchical containers, the notion of nested contexts. So this can be useful if we have a parent context with objects of one scope and child context with different scopes and so on, often in web or service call scenarios. Requests for objects from the child container, if can't be satisfied by child container, will be sent up to the parent container to actually resolve, right? So this is sort of a cascade process where you get to cascade your way through hierarchical containers in order to resolve references to objects and dependencies. It's also extensible, so if you have anywhere in this process that you need to inject some additional behavior of your own, we offer the opportunity to register callbacks to do a variety of things. So the most common one is that you get to modify any object definition. So after the object definition is read, there's a life cycle of the container before the object is instantiated. You get an opportunity to say, it's wonderful that you read all of this object definition from the configuration metadata, but in this particular case, I want to do something else to that object definition. I want to change the recipe a little bit before the object is constructed. So we can modify any object definition after it's read into the container. And we can also change any object instance. So once the container has instantiated it, we can actually modify that object. So if it's read a property value out of a configuration file, but we need a callback that actually does something different or sets a different value for that property that is in contravention to what's actually in the configuration file, for example, then we can change those properties of those objects before they're handed by the container back to anyone requesting the dependency. So let's understand, a lot of what I talked about is very similar, hopefully, to what you're familiar with in Spring Java, of course, and that's intentional. Let's talk about some of the differences, though. Spring Java, of course, is just about at 3.3, I guess, 3.2. And the DI features in Spring.NET are really more similar to what you found in Spring Java circa 2.0, 2.5 or so, okay, in the existing 1.3.2 release that's out there right now. Another big difference that's worth paying attention to is you cannot create custom scopes. Okay? That extensibility mechanism that exists in Spring Java does not today exist in Spring.NET. We've looked several times at this and are continuing to look at it to evaluate whether it's worth doing or not. It's a fair amount of work, as one can imagine. But it's worth noting that you cannot create custom object scopes. In the .NET space, we've certainly covered out of the box virtually all the common ones you'd want. So I spoke earlier about, web request scope, web session scope, these kinds of things. So the usual use cases that most people will come across are actually provided for. But if you have a sort of oddball condition that you need to generate your own custom scope for, we don't presently support that in Spring.NET. We are in the process, as part of the Spring.NET 2.0 release, of syncing container capabilities to be more in line with what's in Spring 3.1.2 and so on and so forth today. It's not the case that at the end of this process, everything that is in the Spring 3X for Java releases will actually find its way into Spring.NET. As I mentioned before, we're looking at these things on a case-by-case basis and trying to evaluate which of them make sense and which of them don't. But a good chunk of that will probably make itself into Spring.NET soon. So here is some standard configuration in XML for .NET. And we're not going to spend a whole lot of time on this because it's certainly something I'm sure you're familiar with before, but all of your favorite things are there. They've just been renamed with sort of a .NET flavor, for example, right? So instead of bean, we get object. But things like constructor arg, things like being able to use a ref tag in order to point to another object declaration and so on are all there. And here we see the parameter at the top saying default auto-wire constructor, so obviously that capability is there too, right? So again, as I mentioned earlier, we have pretty good support for property and constructor auto-wiring in Spring.NET as well. The alternative, as I mentioned before, is the code-based configuration that exists right now in the separate project. You know it as the @configuration annotation approach in Java, but in the .NET space, of course, that configuration annotation is converted to an attribute. But the rest of the behavior is what you're familiar with, right? It's a difference in the annotation model, so the attributes are named a little bit differently. But mechanically, what's actually going on is exactly the same thing that you're used to doing with the @configuration approach in Java. Let's spend a little time talking about the AOP feature set. As I mentioned earlier, the two sort of core engines at the heart of what's going on in Spring.NET are very similar to what those engines are in Spring Java, which is the dependency injection container and a lot of the behaviors provided out of the box by using aspect-oriented techniques. So let's look at what the AOP features are in the Spring framework for .NET. So there is a full-fledged AOP framework. We support point cuts in a variety of different ways, declared by attributes, you know them as annotations, fully qualified name regular expression matching, method name, and any custom point cut declaration as well. So the extensibility mechanism would allow you to define other constraints for your point cut definitions beyond the sort of out-of-the-box support for attributes and regular expression method and type matching names. We support advice. Out of the box, we provide the following advice scenarios. We have before, after returning, after throwing, after, and around advice. So these are not, for those of you that are familiar with developing aspects and all the rest of that sort of thing, these are, you know, pretty much the canonical types of advice that most systems want to support. The AOP features can be used on their own without the use of the container, but this is much less common. Because if you use them on your own, then the responsibility is on you to build the proxy, right? There's a proxy engine in Spring.NET, which is, of course, what the container uses in order to proxy things, to apply aspects and those kinds of things. But it's worth noting that if all you want is the AOP feature set, you do not necessarily need to use the dependency injection container. I would suggest it's almost always easier to use the container to do all the messy work of constructing the proxy and applying advice and the injecting stuff, but it does not need to be used with the actual DI container. We have auto-proxying support. People are familiar in Spring Java with the idea of auto-proxying, the opportunity to say, I don't really quite care at a low level exactly how this proxy is constructed. You just sort of take care of it, and that's what auto-proxying is in the .NET stack. We have an AOP XML namespace. So you can always declare aspect-oriented configuration stuff or configuration values using sort of the longhand, define this object, define this proxy, define this advice, define this interceptor, all the rest of these kinds of things. But the AOP namespace that we provide, as we'll see in a moment in the sample, actually makes it much, much easier for us to sort of have a shorthand declaration for the way our aspects are applied to objects. We also supply a substantial amount of out-of-the-box advice. So not just the framework that enables advice to be applied to objects, but if you write it yourself, but also a number of common advice situations are supported right out of the box with advice that is available in Spring.NET. So we offer advice for logging, caching, exception handling, retry, validation, and transactions. There's lots of other things you might want to use advice for, but these are probably the big ticket items that most people end up applying advice to objects in order to achieve. We provide abstractions for this stuff right out of the box. Excuse me. One thing that's worth paying attention to is that there is not sort of the allegory for the @AspectJ annotation approach that you've probably seen in Java, right? And that's because the infrastructure that enables that to happen in the Java runtime is not available in the .NET space. So this is a sort of technical roadblock that is a hurdle that's not easy to overcome. So it's worth noting that there is this distinction here between Spring.NET and Spring Java. So here's an example of some configuration in an AOP context. And what we've got is we've got a couple of services declared, some log advice declared. We've got a point cut here declared as being a type of attribute. So wherever we've applied this custom attribute to our code, this is where this is going to happen. And down at the bottom, we actually wire the two together, right? So we've got what to do, the logging advice declared. Then we've got the point cut declaration, where to do it. And as I said before, in this particular case, we're saying that we're going to use an attribute match method point cut, which says, go find a method that has this attribute applied to it. And the type of the attribute is going to be this myService attribute. So you can use our attributes, right? So in the case of transaction, in the case of logging, caching, those kinds of things. But if you would like to construct your own attributes, then all you need to do, of course, is create that attribute, and then in the point cut declaration, reference that attribute, and the system will go find where that attribute is and apply the behavior everywhere it finds that. And then in the end, what we're looking at here, and this is using the AOP XML namespace that we have, you tie them together, right? So we say, here's the point cut, and here's the advice. Put those two together. Wherever this is true, apply this behavior. Yes? Yes. So the question is, what does the advice look like when you create it yourself? So we have a couple of interfaces that are provided, right, that you implement, and so we have as well as some convenience-based classes if you prefer to inherit from them, right, rather than implement an interface from scratch. But conceptually, as in the case, let's say of before advice, right? So there's an interface that you implement, and it's literally got one method, invoke, right, and the argument to invoke is the argument to the invoke method is all of the metadata about the method that's really being invoked. Inside the body of your own invoke method, you do whatever advice behavior you want, and somewhere in there, hopefully, you'll eventually call invocation.proceed, which will allow the original underlying method to still fire. Right? Does that make sense? As you can imagine, for things like a round advice, there's a before invoke and an after invoke and those kinds of things. But we do provide, as I said, we provide both the low-level interface so that if you want to implement the entire thing from scratch, go ahead. We also provide some convenience-based classes you can simply derive from and then override a couple of methods that you care about and ignore sort of the rest of the stuff. Okay, so exception handling advice. Exceptions happen, probably more frequently than any of us would like. When they do happen, we support out of the box with our exception advice the following behaviors. Log it, record the exception somewhere. Translate, take the exception that is of one type and convert it into an exception of another type. Wrap, which is take the original exception that was thrown and make it an inner exception of a new exception which we'll throw. Replace, which is forget the original one entirely. We're going to just almost pretend it didn't happen and throw something else entirely. And return, which is, in the end, we probably want to send this exception back as it originally existed up the call stack. And we also support something I hope no one ever does, which is swallow. Right? If you have the world's worst behaving application, you can just apply the swallow behavior for all your thrown exceptions, and it'll be fine. No one will ever complain. But we do support that because there are, in fact, legitimate use cases where you have an underlying thing that you're depending on that is just completely unreliable, and it always throws, or at least 6 out of 10 times it throws. So swallow turns out to be the right answer in some of those cases. And, of course, execute, which is when this exception is thrown, I want you to actually go do something else entirely. As I was talking earlier to the gentleman who asked the question, what does the advice you write look like? I mentioned that the argument to the invoke method that you would write yourself contains metadata about the runtime context of the method that's really being invoked that you're applying the advice to. So in the context of the exception handler, as well as some of the other advice, you get access to the method, you get access to the arguments and the values of those arguments on the method, you get access to the target of the exception, and you also get, obviously, the originally thrown exception that your advice is responding to, right, or our advice is responding to in the case of the exception handler. So let's look at what some of this might look like. here's a very simple example, and you'll probably recognize the syntax as being Spring expression language. When we get an arithmetic exception or an argument exception, go ahead and log it. And what we'd like to log is the method name in this case, right? And you're seeing variable substitution in the Spring expression language statement. Here's a translate. When we get the arithmetic exception, we would rather throw a new system invalid operation exception. And in this particular case, we're actually sending the method name on up and the original nested exception back up. Right? So this means that our code that might have to respond to this exception no longer has to pay attention to arithmetic exceptions because it's not going to get any. It's only going to get invalid operation exceptions. An easier way to write what we just wrote a moment ago is if it's an arithmetic exception, then wrap it in a system invalid operation exception. This essentially says the same thing, right? Because the first one, in the case of translate, you'll notice that the second argument to the translate call when we say new invalid op exception is we're passing the exception, right? We're passing the original exception, which becomes the inner exception. Wrap does exactly that, right? We don't get fine-grained control over what the message name is, what the message text actually is, but wrap can be a shorthand for that. And here we see an example of something that we do all the time, which is, remember I talked about that portable data exceptions abstraction. This is how a lot of that happens. So in the case of a system data SQL exception, if the error number is 154, 165, or 178, what we'd really like to do is actually translate that into a data access exception error. Right? So our code doesn't have to handle system.data.SQL exception or system.data.Oracle exception or system.data.db2 exception and all the rest of these kinds of things. What we do is we take a look at what the error numbers are by looking at the error numbers that come back from exceptions for all these platforms, and we perform on-the-fly translation into these common set of data access exceptions that we rethrow. Retry is another very common advice type. Oftentimes we have methods where we need to do retries, either things time out or services are unavailable and all these kinds of things. And anyone who's ever tried to do retry without advice knows that very quickly what happens is the 3 lines of business code in your object are completely swamped by the 65 lines of retry logic that you have to wrap around it in order to get the retry to work right. So in the case of our retry advice, you notice that we're again using Spring expression language to describe these things. If we get an arithmetic exception, what we'd like to do is retry 3 times, and the rate should be 1 time whatever the heck we passed in plus 0.5. Other options, if it's an arithmetic exception, we'd like to retry 3 times, delayed 1 second in between each. Right? So retry without the delay is basically just going to hammer the heck out of the service in all likelihood. Right? So by adding a delay, we can at least give the service time to recover before we request again. We also support this notion of back-off strategy. So retry 3 times, and the rate this time is actually some kind of back-off strategy where the first time we'll retry maybe 5 seconds, the next time we'll wait 10 seconds before we retry, the next time maybe we'll wait 15 or 30 seconds before we retry. Those are all probably way too long times, right? Let's pretend those are milliseconds. But the point is, right, that oftentimes what you want to do is you want to retry very quickly once, and then if that also fails, then you want to retry after a much longer conceptual duration before you try again. Otherwise, you'll very quickly retry 3 times, you get 3 failures, you're done, no more retry, right? So by having a back-off strategy about the rate, we offer the ability for you to control sort of how that retry actually happens. And this is the only part you need to declare, by the way. What happens with our system and our advice is we understand the Spring expression language and actually configure the retry logic in order to match what the expression describes. And here's an example of sort of how that works. So in this particular case, we've got exception handling advice, and what we're saying is it's retry advice here, and on exception, we're going to retry with a delay and all the rest of these kinds of things. So this is the configuration you would write, and our retry advice actually takes that expression and understands what to do with those inputs. So caching advice. Here's a method called getAirport that takes an ID and returns an airport. And this attribute that we've applied here says we've got this thing called airport cache, and we want the key to be key dash whatever the heck the ID is, right? And the Spring expression language is going to take that ID parameter that's passed into the method and add that to the key that's used in the cache. And we have a constraint here that says, by the way, only do this if the ID is greater than 0. Right? When we actually use this, what we do here is we define ourselves a cache aspect, and you'll notice that it's using spring.aspects.cache.cache aspect that's in our spring.aop assembly, right? So this is advice that we are actually providing out of the box. And then in the configuration for the airport cache, we say what kind of cache it is. In this particular case, we're just using the ASP.NET cache. This is going to use whatever cache your website in ASP.NET in this scenario is configured to use, right? So any valid cache that works for ASP.NET, whether that's in process in memory, whether it's out of process SQL Server, all of these kinds of things will allow us to hook into that. And then we have things like sliding expiration and priority and time to live and those kinds of things that most caching situations support, right? So this is us saying we have an aspect that will work with any caching that your ASP.NET website will support. And so the retry advice, the cache advice rather, is how we actually apply that to the getAirport method. No, so cache here works sort of exactly the same way that cache works in, yes, exactly. That's correct. Yes, and that, yes, that's where I was headed. Right, is that it's a suggestion. If there's a cache, cache it like this. If there isn't, pretend there's no attribute. Good question. Yep, no, it's fine. So in this particular case, right, what we're doing is we're saying that the type of this cache is Spring caching ASP.NET cache, and what that is, as I was saying, is that's a pass-through to whatever the heck cache your website is currently configured to use, okay? We offer other cache adapters other than the ASP.NET cache, so let's see if I can get them all. There are others. There are others, right? So this particular one is just a pass-through to whatever your ASP.NET site might be using. If you have another one, we provide a number of adapters for common caching solutions. It's also extensible too, by the way. So if you want to implement probably iCache provider or something exciting like that, then you can provide your own hook here too. So at a web level, in the context of ASP.NET, we support dependency injection for all ASP.NET artifacts. That's important. So, for example, we support injecting user controls into your page, right? Just as an example, right? When we say all ASP.NET artifacts, we mean that, not just pages and content areas, but also things like user controls. This is non-invasive. There's not a direct dependency on the Spring.NET container required, although very much like the aspect-oriented approach, you benefit greatly when you take this dependency as well as the DI part of the container to do the work. We offer bidirectional data binding. We also, as I mentioned earlier, right, we support web-scoped object lifecycles, so session, request, those kinds of things. We have data model management for form data. So the idea of having a model that represents the form data as an object that data gets bound to. I mentioned earlier the UI agnostic validation framework. That comes into play here. So we can use that framework in order to do data validation and so on, independent of the UI choice. We have hooks that basically take ASP.NET UI controls and wire them up to use our validation framework. So it's possible to say, here's a standard ASP.NET text box, and the validator for this wants to be some kind of validator that we've provided out of the box or that you've written as an extension. We have the notion of externalized page navigation. The idea that we're going to declare elsewhere the relationship between the pages and the navigation paradigm that we're going to use. This works in ASP.NET Web Forms. Some of these capabilities you'll notice actually, if you think about them carefully, if you're familiar with the ASP.NET MVC project that Microsoft has been underway with for a while, some of these you will actually recognize as similar capabilities that are now in ASP.NET MVC. whether it's the idea of data model management for the form data, whether it's the idea of externalized page navigation. We know that as routing in ASP.NET MVC and so on. We've had that in Spring.NET for the ASP.NET web forms for quite a number of years now. Also improved localization and master page support. And I mentioned this briefly before, but I'll say it again. We have direct support for ASP.NET MVC all the way back to the original release at 1.0, but also the more recent 2.3 and just about a month or two ago, the 4.0 release. ASP.NET MVC makes it actually easier for us to do a lot of things. In the web forms world, we had to do a lot of interesting, crazy gymnastics in order to get a lot of that stuff to work in web forms. In the MVC world, because the product was originally designed with dependency injection as an extensibility point, we have, not surprisingly, plugged the Spring.NET framework and dependency resolver into the MVC dependency injection infrastructure so that it seamlessly integrates and can serve up objects as part of page requests and all the rest of that kind of thing. So I mentioned earlier that services were also a very common thing, obviously, that people write. Conceptually, what we're trying to do with services here in Spring.NET is very similar to the idea of what Microsoft was trying to do with WCF. Our approach is a little bit different. WCF is somewhat invasive. Anyone who's ever dealt with Windows Communication Foundation knows that your objects end up with all kinds of fun data contract attributes and other stuff peppered all over the place. Our approach is to say, let's actually just allow us to write our objects that want to be services as plain old CLR objects, and then we'll export them as .NET remoted objects. So if you're using sort of older style .NET remoting, we can expose your object as a .NET remoting target. We can expose your object as a .NET enterprise service. This is not so common as it was a number of years ago, but there are still a number of people using .NET enterprise services, and which is sort of, I guess we can think of that as kind of remoting plus. But if you do have the need for that, we still support exporting your service as exposing your object rather as a .NET Enterprise service. We also support exposing it as an ASMX web service. So if you want to write web services for if your object wants to be available as a web service, it's easy to simply create your object, expose a method, wire it up in the container, and use our service host to expose that as a web service. We basically take your object and wire it up properly behind the scenes in order to expose it as an ASMX web service. You can also, if you are an adopter of Windows Communication Foundation, do the same thing in order to expose your object behavior as a WCF service. We create client-side proxies from the service interface automatically for you. So on the calling side, once you expose the object, we provide these client-side proxies so that you can actually interact with the object natively, or at least apparently natively. Configuration is handled via dependency injection, including things like standard WCF services. You can apply AOP advice to all services that are exported in this mechanism. So whether it's .NET remoting, enterprise services, web services, or WCF services, we can apply advice to all of those things. The common ones, I think I touched on this earlier, in the case of services tend to be things like retry logic and also caching, right? So that you're not constantly hammering the heck out of your service. What you know as Spring remoting in the Java space, WCF is sort of the allegory for that in the .NET stack.
Do you have any help on coding the client for RESTful services?
Yes, and we'll talk about that towards the end, actually. So here's a quick example. This is us taking a calculator service and exposing it as a WCF service. This name here is the same name as you would have in the standard WCF configuration section if you're used to dealing with WCF. One of the important things to pay attention to here is that by default in Spring.NET, just as in Spring Java, object lifecycle is singleton by default. So in the case of WCF, we often, almost always, want to say we would rather use prototype, which of course we know is singleton equals false here, in order to let WCF be in charge of the object lifecycle. And again, we can apply advice using standard approaches here. A couple of different ways to host this. There are sort of two common scenarios for using Windows Communication Foundation. One is hosted in your own application, and the other is hosted in Internet Information Services. Slightly different approach to these. In standalone apps, we need to use something called Service Host Factory Object, which looks like this. And we provide this, of course, spring.servicemodel.activation.serviceHostFactory And this works if you want to host a WCF service in your own process, right? Your application is responsible for hosting the service and dealing with all of that infrastructure. However, if you want to use Internet Information Server, IIS, which is also a very common and probably more common deployment scenario for WCF, we offer the Spring Service Host Factory, which looks like this. And here you see this, of course, in markup in the ASPX page, where we're basically saying the services calculator and the service host factory is what we actually want to instantiate that thing. Spring Data. The feature set in Spring Data is pretty broad. We support, as I mentioned earlier, the ADO.NET framework. We have a lightweight ORM capability in the case of what we call our ADO template. You can think of this as an allegory to what you know in Java as the JDBC template. Right? So if you're familiar with JDBC template, most of the concepts are true in ADO template as well. We have an easy way to invoke store procedures, so if you're in a Sprock-based world, first of all, sorry, but if you're in a Sprock-based world, easy support for that and invocation. I mentioned earlier the portable data access exception hierarchy. This is a really big deal in terms of writing your application to really be database agnostic. We have an abstraction for the transaction manager process, right? So the thing that manages transactions is an abstraction, and we provide a number of implementations out of the box. Declarative transaction management you're all familiar with, and we touched on it earlier, but worth mentioning here because it is a big core function of the Spring Data feature set. We also have data access object support. We have a portable DB provider abstraction. This is the thing that allows us to abstract the different databases that you're working on. It's worth noting that our template infrastructure here does not contain support for the simple bean to table mapping as you find in Java. What we do is we do it the other way, right? So we have support for row mapping in the other direction, so we can take the table data and convert it into an object, but we can't go the other way. This template doesn't support that. However, as I mentioned, there is extensive store procedure support. So in the context of Hibernate Object Relational Mapper, we support all versions of Hibernate going back as far as 1.2. The current release, 3.2, we also support. Actually, I think 3.3, this slide's slightly out of date, but we do support that as well. We have automated resource management as part of this, so managing session lifecycle. As you might imagine, in different application contexts, you want different lifecycle for session. So things like in the web context, obviously per session, per request, per page. In the case of service call, per invocation, those kinds of things. We have integrated transaction management in the context of Hibernate, so we can use Hibernate with whatever transaction manager you've actually chosen to adopt. We have integration testing support for this that makes it very easy for you to use Hibernate to integration test against your database. This is handled, I mentioned this earlier, by wrapping the integration testing inside a transaction, doing a rollback at the end so your database is not a mess. We have our own iBytecode provider implementation. So iBytecode provider is the mechanism by which Hibernate itself generates its proxies in order to support things like lazy loading and so on. Spring.NET, when you use it with Hibernate, uses the Spring.NET bytecode provider in order to get that work done. So it's the same proxy generating engine that is generating the proxies for us in the context of AOP, is also being used to generate the proxies for lazy loading and other stuff like that in the context of using Hibernate. It's non-invasive. You can use standard Hibernate data access objects that you're all familiar with as a pattern, I'm sure. We can think of this generally as being able to say that the support that we have in Spring.NET for Hibernate is really parity with the Spring Java support for Hibernate. The lacking abstraction, such as it is that I'm sure many of you are aware, in the .NET space, there is no allegory for JPA, right? So in the same way that the Java community came together and said, okay, here's JPA as a standard, there is no sort of allegory in the .NET space. So we don't have any kind of relationship to JPA on the .NET side, but we do have parity with Java minus the JPA intermediary. Spring testing. We use dependency injection as an enabler to unit testing. We're probably all of us that write unit tests are familiar with the idea of decoupling using dependency injection in order to isolate dependencies. Typically, Spring is not used for unit testing itself, but we do have support for unit testing. As I mentioned earlier, well, actually, in this case, we can easily retrieve type and objects from the container. We can cache the container across tests, so when you're doing integration testing that does involve your container, we have an infrastructure that handles not needing to spin it up every time, but making sure that it actually is in a pristine state before each test starts, right? And as I mentioned earlier, in the case of integration testing, we have automatic rollback for testing of data access objects. Our support extends to the NUnit framework as well as Microsoft's own MS Test framework. So if you were using one of these two, then a lot of this testing support is available to you. It's worth noting that we do not have an annotation model the same way you have in Java. All right? Which is to say, those of you who are familiar with placing annotations in your unit tests in order to control lifecycle of the container and those kinds of things, that's the part that's not here in Spring.NET, just as a compare and contrast. I mentioned earlier, and we won't focus too much on it, but we have support for scheduling as well as templating. So in the context of scheduling, we use Quartz.NET in the same way that Java uses Quartz. We have dependency injection for jobs, and your jobs can be a plain old CLR object. So in the same way that your services are written as just plain old objects with methods, and our infrastructure takes care of exposing that as a service, your jobs can be written as plain objects, and our infrastructure takes care of hefting that up into the Quartz.NET infrastructure as a scheduled behavior to run. On a templating point of view, we have integration with the Velocity engine, which includes things like configuration support and helper APIs that make interacting with that templating engine much, much simpler. Both of these are able to leverage general container features, so whether that's aspects or dependency resolution or runtime versus compile time configuration and all the rest of these kinds of things. Things like property placeholders and resource loading and those kinds of things are available because it's the container's job to sort of heft this thing up as a scheduled object or heft this thing up as a templated object. And once the container's involved in that object lifecycle, it's possible for all of the rest of the infrastructure to obviously come into play and benefit us. We can think of this as being comparable and providing parity with what you know in the Spring Java framework. At a messaging level, the whole idea was to remove an awful lot of boilerplate code that people tend to deal with when dealing with send and receive in messaging. We make it dirt simple for you to create multi-threaded listener containers, right? So anybody who's dealing with messaging probably knows that you want to actually be able to dequeue things more than one message at a time. Sometimes actually one message at a time is important, but more often than not, multi-threaded queue listeners are important. So we have an infrastructure that makes it very easy for you to develop those and configure them. Again, using a plain old CLR object-based programming model. So message handlers and so on are written as plain objects and wired into the listener container as the handler for those particular message types. We have a variety of supported technologies out of the box. We support ActiveMQ, TIBCO, and of course because it's a .NET project we have to support MSMQ, I suppose. But we support all three of those messaging buses out of the box. Just to give you a sense as to how easy this is, here we have a method called generate fake market data, and all we're doing is using, in this particular case, the TIBCO EMS template, and we're calling convert and send and passing the data. Right? It's literally this easy.
How easy it is to drop your message in MSMQ in Java environment? Can I use MSMQ in Java?
It's an interesting question. I don't know the answer to that. But I do know that I probably wouldn't be picking MSMQ if you have a heterogeneous system. My suggestion would be to select a different messaging bus than MSMQ if you've got anything other than .NET talking to it. One of the biggest problems with MSMQ, of course, is that it only runs on Windows, right? So you're sort of already platform locked at that stage. But it is very easy, as we'll see in a moment, and part of the point of this, right? Part of the point of this parity is that what you'd like to be able to have is, regardless of your messaging bus choice, you'd like to have the code that adds messages to the bus and the code that dequeues messages from the queue to have similar capabilities on both ends of that messaging pipeline, right? Whether it's Java sending the message and .NET receiving it, or .NET sending the message and Java receiving it, you'd like to have a similar sort of programming paradigm on both ends of that communication, right? So you're not learning one API over here, learning a whole other API over here. And obviously what we're doing with messaging here and the parity that we have with Spring Java enables that kind of similar programming paradigm to be true. We also offer Visual Studio tooling. So, yeah.
Do you support the transaction between, how is the transaction support between messaging, for example, and database? Are they same transaction content or?
So.
For example, if I receive message from message queue and I put it to something in the database, I got
So let's make sure I understand the question, right? Because I think there are two scenarios there, and I want to be sure I'm talking about the right one, right? One scenario is on one side of the message bus, I begin a transaction, I enqueue a message, it transmits, it's dequeued. Now the dequeue process needs to do something to a database. Something goes wrong. What happens when I roll back that transaction, right? And that is supported, but only with distributed transactions, right? And I would argue to avoid those wherever humanly possible. But that is supported. We have so remember I said we have a transaction manager abstraction. One of our transaction manager abstractions is the Microsoft's TX Scope transaction manager, right? And that thing will deal with the Microsoft MSDTC, the Distributed Transaction Coordinator infrastructure, and make all of that work. I would suggest you want to try and avoid that, because what you're ending up with is, because messaging is inherently asynchronous, you're ending up with a transaction that's going to be open for a very long time, potentially, relatively speaking, before it eventually commits. What I would suggest as an alternative, and this is supported very easily, which is the transactional dequeue. Right? So I don't open the transaction when I transmit the message. I begin the transaction when I dequeue it. So the act of dequeuing the message and trying something in a database that may fail and need to be rolled back, in which case the message is re-enqueued, that is supported. Right? And that's much easier to sort of do and manage and deal with than the begin the transaction on the transmit of the message. Right? So in the context of Visual Studio tooling, we actually don't have, unsurprisingly, anything on the same scope and scale of what you have in the Java space with the Spring Source tool suite. Largely because Visual Studio is sort of the big daddy in this space and is nowhere near as extensible as Eclipse is. In recent years that's changed a little bit, but for many, many years Eclipse was obviously eminently more configurable than Visual Studio. However, we do have some tooling that we provide in order to make it a little bit easier to deal with some of the Spring.NET scenarios. We offer an add-in for Visual Studio that provides the following features. We have type complete, and this is all about editing XML files, by the way, but we offer type completion, we offer property name completion, we offer constructor arg name completion, and we offer property value completion if your property is of type or an enum. And we also have snippets that make common bits of XML easier and more accessible to you as you might be writing configuration. And lastly, we have the ability to sort of get quick info from XML comments in code. This is an animation which I will run here briefly and just talk through as we go through it that sort of demonstrates kind of how this works. So we have an enumeration defined right here. We have an interface of type I class and a concrete implementation class 1. It's got a type property and an enum property and two constructors with named different arguments. If we go to an XML file, what we can see here is the first thing I'm doing is declaring an object. You'll notice that I get IntelliSense completion for my type. So all I need to do is type class 1 and it completes that for me with the fully qualified type name. In the case of constructor args, notice when I say name, I get IntelliSense completion for constructor argument names as well as pop-up tooltips telling me what type they actually are. This particular thing has a property of type name. You notice that I get enum property and type property, so that's my properties showing up in IntelliSense. And I also get enum completion showing me what the available enumerations are for that particular property. In the case of type property, what I can do is when it comes to value, notice that IntelliSense gives me, again, the opportunity to do type completion very quickly here. The next thing I've got is I've got snippet support, so I very quickly want an object name auto proxy creator, and it goes on ahead and stubs out the common XML for me and allows me to fill in the missing values. The next thing we've got going on here is you'll notice that, again, I get type completion here. In this particular case, placeholder configurer, minus a typo or two. And what you'll notice is that if I hover over this, maybe we're not hovering just yet. Right? Property name completion. Notice the IntelliSense shortcuts here telling me in tooltips from the XML comments in the code what these actual properties mean and what their values are and all the rest of that. So we get inline help. And again, because it's an enumeration, I get type completion for the enumeration there in the property value. And I can actually hover over any type, so here I am hovering over class 1, and I'm seeing the XML code comments for type 1 telling me what the heck this type actually is. So some of the XML syntax highlighting and some of the XML snippet support, the XML IntelliSense and so on, is a function of Visual Studio's own ability to hook up to the XSD schema definition for the XML file. But things like type completion, property names, enums, all of that is a function of our add-in here. Okay, so we've got about 10 minutes. Let's quickly look at interop scenarios. This is pretty common. Most organizations that have a mix of .NET and Java, and for that matter other platforms too, eventually find a need for the systems to talk to each other, or at least play nice together with common data. So we're going to look at a couple of solutions to this in brief. So the most common scenario to this, and this goes back years and years and years and years, is the whole notion of resource sharing. We know this as commonly network stored files or commonly network accessible databases and so on. If you've ever done integration at the file level or integration at the database level, you know that while this works, it's not without its own pain points. So another approach to this is in-process interop. We have things like code translation, where we literally take Java code and turn it into C# code, or of course C# code and turn it into Java code. We can do this at the bytecode level, so examples of this that convert bytecode to Microsoft Intermediate Language, things like Grasshopper, ikvm.net, and so on. These literally take the compiled bytecode or intermediate language from either platform and convert it into the other. We can also do source translation. Rather than at the binary level, we can do this with a .cs file or a .java file, and things like JLCA or J2CS translator and so on do this too, to varying degrees of success. Again, it's unlikely in any modern application today that you would literally be able to push the translate button and then just compile it in the other platform. Those days are probably long since gone. Another approach to this is bridging. So things like CodeMesh and JNBridge Pro actually enable you to take .NET objects and translate them to Java objects or vice versa inside your single process. More common today are not the resource sharing, although that one probably integration at the database is still sadly much more popular than it should be. But the code translation and bridging approaches have sort of fallen out of favor in favor of things that happen over the wire instead, that allow each platform to continue to operate somewhat independently, but then use wire transfer processes to actually exchange information. So one of the most common for this years ago, not so much so anymore, is the whole idea of bridging. We saw this in Corba for Java, and we also see this in .NET remoting. There's the ability to use .NET remoting to talk to a Corba provider and vice versa. It's brittle, it's hard to make work, it tends to be susceptible to breakage and these kinds of things, so not so common. More often nowadays what we see are things like web services and the sort of contract first approach. We know this as SOAP and all the rest of this stuff. And also, of course, nowadays things like REST, where we're just using HTTP to exchange data payloads in what, at least in theory, promises to be a much simpler solution, probably until we start layering security and all kinds of other fun things on it. Another approach to integration is message-oriented middleware, right? Whether it's JMS or AMQP and all these kinds of things. Message buses are a tried and true from the ages integration technology. Also, we start to see things like in-memory data grids. We know these as things like the Gemfire solution, as well as Oracle's Coherence product and so on. So let's talk about AMQP briefly. Spring AMQP offers support for both Java and .NET. A common AMQP model. We define messages and message properties, of course, common exception hierarchies, abstraction for client libraries. Ultimately, on the .NET side at least, we plan to support more than just RabbitMQ, but for the time being, that's what our focus is. We're starting with integration for RabbitMQ. We have broker administration support. We can declare exchanges and queues in Rabbit, bind queues to exchanges. We have resource management, so things like the connection factory is a strategy. It's suitable for dependency injection for resolution. We support caching of connections and channels for performance reasons and these kinds of things. Interacting with this, if you're familiar with JMS, should be fairly familiar to you because we tried where possible to sort of keep things in a similar meme. So you can obviously see JMS on the left and RabbitMQ on the right and realize the combination or the commonalities across them. We have an AMQP template. This is what the API looked like, at least when I made the slide. You notice things like send, receive, convert and send, receive and convert, that dequeue messages and convert them back to objects, all the rest of that kind of stuff. We also have support for administration. Here's what the admin API looked like. Declaring queues, declaring bindings to queues, declaring exchanges, deleting them, those kinds of things. Currently, this is all Erlang RPC based, but we plan to move to the REST interface at some point in time as well for this. Spring Gemfire, very briefly, the Spring Gemfire project. How many of you are familiar with Spring Gemfire? Costin, you don't count. So Spring Gemfire is a top-level open source project. It's available here at springframework.org/springgemfire. And the idea here, of course, is to enable use of the Gemfire distributed data grid within Spring applications, both for .NET and for Java. The .NET support only extends as far as Gemfire 6.0 and 6.5, whereas the 7.0 support is in Java. On the .NET side, these are the things that we're supporting. So IOC, configuration of cache, regions, client region, cache loaders, cache listeners, and writers. Exception translation via use of the repository attribute. We know these as stereotypes, right? At repository in Spring Java and so on. Configuration namespace for caching regions and factories. iDictionary for regions, message listener in order to respond to messages in the context. We also have caching advice that hooks into Gemfire. Mentioned before the whole idea of cache providers working with the cache advice. We have one for Gemfire. Briefly talk here about Spring Social. So Spring Social on the Java side involved a variety of different projects. We have similar projects for some of these on the .NET side. Social Core is where we actually have our OAuth support infrastructure that drives a lot of the rest of this kind of stuff. We have support for Twitter, Dropbox, and LinkedIn on the social side. These are reasonably complete, comprehensive ports of what's going on in these stacks in Java, near parity. REST. Somebody asked me earlier about REST support. So Spring REST for .NET is absolutely a project, and it's definitely how we recommend you look at accessing REST capabilities. We provide something called a REST template, which for those of you that are familiar with the templating approaches for things like JDBC template, Hibernate template on the Java side, and so on, this should look very familiar to you. It's exactly the same sort of paradigm of operation. It is the infrastructure beneath many of the Spring Social offerings. So since a lot of those social platforms are using REST APIs, the Spring Social for .NET projects are using Spring REST to actually facilitate most of that communication. Spring REST actually has support for Silverlight 3, 4, and 5. So if you need access to REST services in the context of Silverlight, any of those versions are supported. Also supported on Windows Phone 7X, so up through the recently released 7.5 and will be 7.8 when it finally comes out. We don't know about Windows Phone 8 support because nobody knows about Windows Phone 8 yet. But we'll try and make it work when it comes out. We also have async invocation using the .NET 4.0 TPL, the Task Parallel Library. So anybody who's ever dealt with calling web services, whether they're REST or otherwise, knows that asynchronous invocation can be a really big part of that because you don't want your UI locked, especially in the case of something like Silverlight, where you only get one thread. So blocking the UI is a big old no-no. So we use the .NET 4.0 Task Parallel Library for async invoke on some of these things where possible. We also provide an infrastructure that allows us to conveniently mock REST service calls so that if you're testing your API and don't want to really talk to the service, our testing infrastructure that ships with Spring REST for .NET actually allows us a very easy way to mock out those things. As a wrap-up, and I'm just about on time here, where are we with Spring.NET? So upcoming is the 2.0 release, probably in about a month, hopefully a little less. Among several things, we'll have a modernized container API that more heavily leverages generics. We'll be introducing a fluent code-based configuration. In addition to the @configuration approach, we'll also be doing declarative code-based configuration in a sort of more fluent style. With Spring.NET 2.0 will come our support for MVC4, including support for MVC4's new web API, which is sort of Microsoft's re-envisioning of the WCF REST approach. But we do have support for that as well. Where with Spring AMQP and Gemfire for .NET? We are slightly behind the Java versions in our release train, but we are catching up. And we are presently in the process of carefully evaluating the Spring data projects for those that might have applicability to the .NET space, right? A lot of what's going on in the Spring Data projects in terms of support for non-relational data stores, whether it's Neo4j or MongoDB, these kinds of things, there's probably a fair amount of that stuff that has validity in the .NET stack as well, and so we're evaluating those projects to decide what to bring over and sort of when as well. And that's the end, so I am done. Any questions?
Do you have any support for WPF?
No, there's not presently support for WPF directly. You can use the container in WPF projects, but there's no inherent capabilities that are directed at WPF. That's a good idea. That's a good idea. We don't presently do that. Yes?
How then security handle, for example, in web applications? Do we have something clear with Spring security?
No. So one of the things that is not, one of the things for which there is no allegory is the Spring security. We've looked at that several times, and one of the challenges we have is that Microsoft, for a variety of their own reasons, tends to be continually re-envisioning what they imagine the security model to be. So we've seen things like Windows Identity Foundation and these kinds of things start to come out, and our conclusion is that in the .NET stack, there's so much churn going on there that it's almost impossible to sort of solve that right now. If things settle down, I think there's reason for, I mean, there's obviously value in Spring Security. The question is, what does it sit on top of in the .NET stack, right? And the challenge is that there's just so much movement in that area in .NET that it's very hard to sort of decide what the underpinnings of that would be. Yeah, that's possible too. Yeah, that's possible too. I think the challenge is that when we look back to our original strategy of sort of embracing and extending the base class library, it becomes one of these things where we don't want to introduce something that is sort of contrary to what's going on in .NET, right? We don't want to be fighting with them because that's pointless. We want to try and enhance where reasonable. And it's one of these things where we could definitely sort of strike out on our own with Spring Security and say, look, here's how since you're not going to solve this timely, we'll solve it for you. The problem is that tends to work better in the Java space for a variety of cultural reasons than it does in the .NET space. Yes?
Is there any support or planned support for Spring integration?
So yes and no. So there is an existing port of Spring integration that is current as of about Spring integration 104 or so. The core functionality was all ported over and actually does work and so on. And the next step in that process is for us to actually create channel adapters and all the rest of that kind of stuff, right? So the core functionality in Spring integration actually was ported over about a year ago. And it hasn't really been kept in sync, so there would be a synchronization effort there. But what's really missing there is an effort to actually start building out the infrastructure of channel adapters. It's definitely an area that we're looking into and trying to evaluate whether there's merit in sort of continuing that process or not. Certainly, a lot of the interop scenarios and so on are helped by having Spring integration on either side potentially. So there's definitely a synergy there that we're clearly investigating. Anybody else? You had a question? They will be available, yes. I will make them available somehow. Come see me for a business card, and at a minimum, I will email them to you if the conference cannot figure out where to post them. You had a question there.
Yes. So we have a pretty large project we're looking at DI injection. The front runner for us is actually structure map, right?
Okay.
I was wondering if you had any opinion on
So here's what you end up with. And so I know Jeremy Miller, and I like structure map quite a bit, right? But in fairness, to compare structure map to Spring.NET is sort of an apples to oranges comparison for the following reasons. I sort of classify DI containers into three categories, and it's not a categorization based on quality of code or anything like that. But in the context of AOP, there's sort of three different tiers, right? So tier one is those things that are an IOC container. They have their own dynamic proxy engine, and they provide abstractions for declaring aspects and advice and point cuts. Right now, today in the .NET space, that's only Spring.NET. Tier 2 containers are those that are IOC containers. They have their own dynamic proxy engine, but they lack any abstraction libraries for aspects and point cuts and advice and all the rest of that, right? Those are things like Castle Windsor. They are things like ninject, and so on. Third-tier containers are things like structure map, for example, that are very capable IOC containers. They don't have their own dynamic proxy engine, but they have a way for you to wire someone else's in, okay? And, of course, they also lack any abstraction hierarchy for aspects and advice and point cuts and all the rest of that, right? So when you're picking a dependency injection container, if core DI is the only functionality you need, then any one of those three tiers is perfectly valid to pick from. After that, if you also want to do things with aspects, the next part of your discussion is how much of that do I want to write, and how much of that do I want a framework to provide me? And that's the guidance that you use to pick, right? And so in the case of structure map, for example, there's no declarative transaction management. If that doesn't matter to you, then structure map may be a perfect answer for you, right? And if you want to do declarative transaction management, then it's not only up to you to write the transaction advice, it's also up to you to wire in someone else's proxy, declare your own point cuts, declare your own mechanism for identifying point cuts, you know, and all the rest of this kind of stuff, right? And so, and that's why I say it's sort of an apples and oranges question, right? From a pure DI capability, I like structure map. I think it's a great tool. I've used it myself on projects for many, many years, right? But I think the question is sort of what do you want out of it, right? And that's where I'd go, right? If you, and the challenge becomes one of like, if you think you only want it for DI and you're right, then that's fine. If you think you want it for DI and now you suddenly decide, oh wow, you know, retry advice would really be helpful here, you're kind of stuck.
Yeah, we ended up going with PostShark for aspects, but that has its own.
Yep, absolutely. Yep, absolutely. Right. So IL weaving compile time stuff is perfectly valid as a match with that too. Right. You don't need to do AOP using your container. Right. You can clearly do it using other techniques, especially in the .NET space. Any other questions? Then I think I got to get out of here for the next speaker. Yes.
Examples for source code somewhere in the example somewhere.
I'm sorry, for what?
For any example for Spring.NET, any source code what we can use for learn ourselves.
Oh, sure. So if you go to, so we're on GitHub. If you go to springframework.net on the web, what you'll find is a whole slew of links and so on to the GitHub repository, which contains those 16 or so samples I was talking about, as well as all kinds of getting started documentation and so on and so forth. And because it's an open source project, of course, the source code for the framework itself is available right there for you. Yep. If anybody else has any questions, I'll hang out in the hall after I collapse and get out of this
Sorry.
next team's way.